Objectives. General. Immobilized enzymes by a treatment technique with sodium alginate of the alpha-amylase extracts obtained by liquid fermentation HF and solid-state fermentation SSF. Particulars. Use of extracts of Saccharomyces cerevisiae SSF, Aspergillus niger SSF, and Bacillus subtilis HF to form the samples of beets, and demonstrate that sodium alginate is effective for alpha-amylase immobilization.
Well, in introduction, enzyme immobilization. Enzyme immobilization is a process which an enzyme gets confined on a defined space, region, to give place to insoluble forms that retain their catalytic activity. This can be repeatedly utilized. In this definition has been extended into the process that they are restricted partially or complete form. We use the degrees of freedom of movement of enzymes, organelles, cells, etc. for its union to the support. There are advantages and disadvantages of using immobilized enzymes. On advantage, we can increase the enzyme stability. We can reuse the derivative and decrease the process cost, and we possibly design an enzymatic reactor to use and control for the correct application. The disadvantage of these methods are the enzyme conformation is modified, the system enzyme support, heterogeneity can exist different enzyme fractions, and this can decrease enzyme activity. There are different kind of immobilization methods. These immobilization methods depends on the support we are going to use, and these can be pretty different because the chemical and physically process, like chemically it's absorption and covalent bonding that it talks about support and cross-linking. Like we can see in the image, there are the form and the mechanisms of each method. The physically that we are going to talk is about entrapment. Well, entrapment, that is an irreversible method, and this can be a trap as support for inside of fibers. Like we can see in the next image, these can be polymer membranes that allows the substrate and the products to pass through the fibers of but retains enzyme. This is the main mechanism that we need, and this method permits the ability to modify the encapsulating material, and we can create an optimal microenvironment for the enzyme, like optimal conditions like pH, polarity, or amphilicity, that is like lipophilic or hydrophilic characteristic. We can do the gelation for polyanionic or polycationic polymers by the addition of multivalent counterions. The most common polymers that we use as a matrix are alginate, carrageenan, collagen, polyacrylamide, and gelatin. This is mentioned by Mohammad Marzuki, Bouin, Huyop, and Abdul in 2015. We talk about the entrapment, and we use sodium alginate. This is a major structural polysaccharide that came from the brown algae and contains beta D monopyranosyl uronate and alpha L gulopyranosyl, and these are homopolymeric sequences that are found together in the presence of monovalent cations. This polysaccharide forms viscous solution And in presence of divalent cations like 2 plus calcium, this gelation occurs. This method can be used for immobilizing enzymes, drugs, cells, or proteins. And this came from Mahajan, Gupta, and Sharma in 2010. We can see in the image. These are the sodium alginate, and when it's in presence of calcium chloride solution, this transforms into calcium alginate. Like we can see in the image, the sodium alginate, it's in calcium chloride solution, and this creates an hardened solution of calcium alginate. This hardens the spheres that entrap the enzymes, and this permits the flux between the substrate and in this active site of the enzyme. So we can see like this is the principal methods that we are going to achieve for this immobilization, for this enzyme immobilization of alpha-amylase.
For this practice, we read some articles. The most important for we is that written by Sarmiento, which say that concentration of alginate of optimum is the 3%, and the concentration to calcium is the 0.5 molar. To know a method to quantify proteins, the method consists in weight 0.5 grams of spheres and mix with 4.5 milliliters of buffer pH 6.6. Have a temperature of 30 grades centigrade. The spheres are dissolved. Shake the solution in water for 5 minutes and quantify proteins by the method of Bradford. Our results for Aspergillus niger are the next, where the dark blue is 2 spheres and the light blue is 2 supernatant. The average on spheres is 13.45 and for supernatant is 10.125. Our results for Saccharomyces cerevisiae are the next, where the dark blue is 2 spheres and the light blue is 2 supernatant. The average in spheres is 18.14 and for supernatant is 3.25.
The results for Bacillus subtilis are spheres is 51.35 and the supernatant is 0. And the result for commercial enzyme, the result of commercial enzyme are spheres is 57.52 and the supernatant is 5.37.
About the treatment technique. Although many mobilization techniques have been developed and applied to numerous enzymes, it is recognized that there is no universal method valid for all enzymes in all cases. In general, the preparation methods and higher costs provide more stable and durable biocatalysis. On the other hand, simpler methods such as entrappement or absorption, where the binding of the enzyme with the support is weak, originate immobilized derivatives that show loss of activity and that must be replaced continuously. Why sodium alginate? It has been reported that the degree of cross-linking of the gelling agent affects the size of the beads. It was found that the immobilization efficiency was higher for 3% of sodium alginate. According to Mamarella, the higher the concentration of calcium chloride in which the sodium alginate beads are suspended, the gel will be more rigid because there are more calcium plus 2 ions with which the alginate gel reacts. The size of the cones must be the same as the substrate, and the product are easily disseminated on the outside. The alginate matrix is obtained, but the enzyme must retain the microenvironment of the pearls. Putting down the sodium alginate solution concentration, major is the pore size of the beads, and consequently the leak of the increase in concentration of sodium alginate solution.
We use the method of Day to calculate the efficiency of immobilization. The emission when using an alginate concentration of sodium 3% had an immobilization efficiency of 50%. Our efficiency results in 3% sodium alginate are 4.81 of Aspergillus niger, 70.46 of Bacillus subtilis, 19.72 of commercial enzyme, and 24.39% of Saccharomyces cerevisiae for every 0.5 grains of sodium alginate beads.
Well, as conclusion we have that the enzyme entropium was successfully achieved by the alginate support and then suspended and stored in phosphate buffer, having as recovery efficiency the following dates, showing a better performance of the procedure, the enzyme obtained for Saccharomyces cerevisiae. In the case of recovery of the enzyme, there is a good percentage as shown in Table 1, which shows that the alginate is a good support for the trapping of alpha-amylase.